If you wanted to see the list of programs on television, you would refer to a television program list. When chemists want to find out about the elements, they refer to a list of chemicals, called the periodic table. The most commonly used method of organizing the elements is the periodic table. The periodic table is a way in which the elements may be arranged. This system was developed by Dmitry Mendeleev, who lived in Russia from 1834 to 1907. Mendeleev was a chemist. He developed the periodic table in 1859. His system is useful, since it helps scientists to see the lists of elements in groups according to different factors such as state of matter, atomic mass and atomic number. The system is called the periodic table because the elements are arranged in periods or groups. Over the centuries, scientists have tried to organize the elements in various ways. At the current time, there are approximately 118 elements. Scientists find more elements as they continue their investigations. There are even elements that scientists know exist somewhere in the universe, but they still need to be discovered. If you look carefully at the periodic table, you will see that it consists of columns and rows. The columns are called groups. There are 18 groups, numbered from 1 to 18. The elements in each group have various properties that are similar. For example, the elements in group 18 are called the noble gases since they do not combine with other elements. The rows are called periods. There are 7 periods, numbered from 1 to 7. Period 1 only has 2 elements that are hydrogen and helium. Periods 2 and 3 have 8 elements each. How many elements are found in period 5? You can easily find the position of an element on the periodic table. For example, carbon is found at group 14 and period 2. Each element is represented by a symbol. This is an abbreviation of the full name of the element. For example, carbon is abbreviated with the letter C. We call these abbreviations chemical symbols. You will also notice that in each block, there are 2 numbers. The number at the top represents the atomic number. The atomic number tells the scientist how many protons and electrons the atom possesses. Remember that the number of protons and electrons must be equal for balance to occur in the atom. The elements on the periodic table are arranged from the lowest atomic number to the highest atomic number. The first element has an atomic number of 1. The last element has an atomic number of 118. The number under the symbol is called the atomic mass. The atomic mass is the total mass of an atom, and includes values of all the protons, neutrons and electrons. In this example, carbon has an atomic mass of 12.011. Here is a list of all the elements that are found on the periodic table. Can you find hydrogen, oxygen, carbon and helium on the list? Which other elements that you have heard of are on the list? This shows the elements from atomic number 61 to 118. Look at some of the names of the elements. How do you think the elements Einsteinium, Mendeleevium and curium got their names? They are all named after famous scientists. Other elements such as europium, americium and californium are named after places. There are several other ways of identifying the elements. Elements can also be identified as to whether they are metals, non-metals or metalloids. On the periodic table, the line dividing the metals and nonmetals looks like a staircase. So, the area of the periodic table where the metalloids are found is called the staircase. The metals tend to be positioned on the left side of the periodic table. The non-metals tend to be positioned on the right side of the periodic table. The metalloids are positioned between the metals and non-metals. The metalloids may have properties of both metals and non-metals. Let us compare the characteristics of metals, non-metals and metalloids. Metals are good conductors of electricity, whilst non-metals are poor conductors of electricity. Metalloids may be good or bad conductors of electricity. What about the conduction of heat energy? Metals are good conductors of heat energy whilst non-metals are poor conductors of heat energy. Metalloids may be good or poor conductors of heat energy. Malleability refers to how well a material can be molded into other shapes. Metals are easily molded into other shapes whilst non-metals cannot be molded into other shapes. Metalloids, however, may or not be malleable. Ductility refers to how well a material can be stretched. Metals are easily stretched whilst non-metals cannot be stretched. Metalloids, however, may or not be ductile. The melting point of a material refers to the temperature at which the material becomes a liquid when heated. Different materials have different melting points. Metals are solid at room temperature. Therefore, they melt at high temperatures. Non-metals are gases at room temperature and melt at a low temperature. Metalloids may melt at high or low temperatures. Finally, the reflective property of a material is an important characteristic of materials. Metals are very reflective and are therefore said to be shiny. Non-metals are not shiny because they are gases. Metalloids may or not be shiny. This table shows a list of all the metals. These tables show the lists of metalloids and non-metals. Download a blank copy of the periodic table from the internet. Color all the metals with green. Color all the non-metals with blue. Color the metalloids with yellow. Draw the staircase with a red pen. Let us summarize the main points that you have learnt. The periodic table is a list of the elements. The periodic table was created by Mendeleev. The periodic table consists of periods and groups. Each element has a symbol, atomic number and atomic mass. The elements on the periodic table may be grouped as metals, non-metals and metalloids. Metals, non-metals, and metalloids have different characteristics or properties.
Ha